Okay, students, welcome to the session. So, in the last lecture, what we did, we have discussed about multiplication of matrices, means how we can multiply two matrices and then under what condition they can be multiplied with each other. After having an idea of the multiplication of matrices, we discussed some basic properties which must be satisfied by the matrix multiplication. And among all those properties, one property was very common, that is matrix multiplication is not commutative. Commutative means if A, B are any two matrices, you are finding out the product A, B and then reverse the order of the matrices, then you find out B, A, then the product A, B and the product B, A both are not always same or equal. That is why we generally say that the matrix multiplication is not commutative in general, and we have also seen there are few examples in which AB is not equals to BA, but I have given you one example in which AB is equals to BA. So in continuation, after that we discussed the integral power of the matrix. Integral power of the matrix means if we can multiply two matrices, so naturally we can multiply a matrix with itself. So if a matrix A is multiplied with itself, we will get A raised to power 2. And if A square is again multiplied with A, we will get A raised to power 3. So by doing this, we can have or we can find out any integral power of any matrix. So after that, let us have two basic matrices which are considered of important. One is the idempotent matrix and the other is involutory matrix. Idempotent matrix means a square matrix A is called idempotent if A square is equals to A. Means for any square matrix, if we multiply A with A to get its square, that is A square, if A square is the matrix itself, that is this condition is satisfied, then the matrix A is called idempotent, right? This is an example of an idempotent matrix. If you take A is a matrix like this, find out A square. See, A square means A is multiplied with A itself, then the product is coming out to be the matrix A itself. You can check the product of A with A remains the matrix A itself. See the first row, you know the process of finding out the product of two matrices. This is the first row. This row should be multiplied with the first column. Then this row should be multiplied with the second column. Then the same row should be multiplied with the third column. Then take the second row of the first matrix. Second row should be multiplied with the first column. Then second row should be multiplied with the second column. Then second row should be multiplied with the third column. And finally, we will take the third row of the first matrix. It should be multiplied with the first column, second column and third column of the second matrix. So using this operation, you will get the product of A into A as this matrix, and this is the matrix A itself. So this is the example of an idempotent matrix, means A square is equals to A. Second is involutory matrix. So likewise, a square matrix A is called involutory if it satisfies this condition, right? A square is equals to identity matrix. I denotes identity matrix. This is the example of an involutory matrix. A is equals to this. If you multiply the matrix A with itself in the same operation what we did in idempotent matrix. So this A is multiplied with A itself, the product is coming out to be identity matrix. Let us give you one case. The first row should be multiplied with the first column. So minus 5 into minus 5 minus 8 into 5 plus 0 into minus 1, right? minus 5 into minus 5 minus 8 into 3. First row with the first column, minus 8 into 3 and then 0 with 1. This is 1. What you will get? Minus 25 minus 8 3 the 24, and this is what? This is 0. So 24 minus 25 minus 24 you will get here as 1. So using the same operation of what? Multiply the first row of the first matrix with all the columns of the second matrix, then second row of the first matrix with all the columns of the second matrix, then third row of the first matrix with all the columns of the second matrix. So after using this operation, you will get the product of A with A itself as an identity matrix. So these two examples are the examples of two specific type of matrices, the idempotent matrix as well as involutory matrix, right? Now, after having the basic idea of the matrices multiplication, then there its properties, and then its integral power, and then its specific types of matrices, now we can proceed for the numerical questions based on theory of matrices. So this is an example. If A is equals to this matrix and B is equals to this, then find AB. This is a very simple case of product of two matrices. This is A and this is B, right? And we know both are rectangular matrices. If you recall my last lecture, what I have told you, whenever the two matrices you are going to multiply, they are square, then you have nothing to check. They will automatically satisfy the basic requirement for the multiplication of two matrices. However, if the two matrices are rectangular, then you must check whether the condition of the product is satisfied or not. Then you can proceed them for proper multiplication. And the condition is what? A is this, B is this, then find AB. AB means the columns of A should be equals to rows of B. This is the basic prerequisite condition under which two matrices A and B can be multiplied, right? So how many order of A is what? A is having two, it contains 3 rows and 2 columns. B contains 2 rows and 3 columns, right? So what is the condition? Condition is this: A contains 2 columns and B contains 2 rows. So the condition of the product is very much there. We can multiply A and B to find out the product B. The next question is what? What is the order of the product? And I have told you the order of the product is 3 by 3, right? So let me write very clearly. Say A is a matrix of order 3 by 2 and B is a matrix of order 2 by 3, right? See, this is what? This is the condition for product of A and B. And this is what? This is the order of the resultant product AB, which we will obtain after multiplying A and B. So what does it mean? AB is possible, and we can also tell about the order of AB, and we know from this order, the order of the product AB will be of 3 by 3 matrix, right? So see, you can proceed. This is the matrix A and this is your matrix B. Now see, the product is here. The first row of matrix A contains 2 5. So this 2 5 should be multiplied with the first column of this. Then the first row of A should be multiplied with the second column, and finally the first row of A should be multiplied with the third column. So we are getting this, this and this, right? Then you will multiply the first row of the first matrix with the first column of the second matrix. You will get the first element of the first row of the product matrix, right? So when the first row 2 5 will be multiplied with 5 4, you will get this. So 2 into 5 plus 5 into 4, the first element. 2 into 2 plus 5 into 3, second element. 2 into 1 into 5 into 0, third element, right. Now come to second row, 1 1, 1 into 5 plus 1 into 4, second element, right. 1 into 2 plus 1 into 3, second element. 1 into 1 plus 1 into 0, third element of the second row. Now come to third row, 3 2, 3 into 5 plus 2 into 4, this, 3 into 2 plus 2 into 3, this, 3 into 1 plus 2 into 0 is this. Now you can simplify it, and then finally you will get this AB as a product, and you can verify that the order of this product is 3 by 3 because it contains 3 rows and 3 columns, right. Case 2 is what? If A is a square matrix, compute A square for the following matrix A. So here this is the matrix A. We have to simply find out A square. A square means multiply A with A itself to get A square. As we have discussed the integral power of a matrix, if a matrix A is multiplied with itself, then we get A raised to the power 2. The integral power of A is 2. Similarly, if you multiply A raised to the power 2 with A itself, you will get here A raised to the power 3. And if A raised to the power 3 is again multiplied with A, you will get A raised to the power 4. So using this operation of the product or multiplication, we can find out the integral power of any matrix up to any order, right. So students, let us have this example. Actually, this is a word problem, and I solved this word problem because you should understand the basic applications of matrices, how matrices are being used in various practical aspects. So this problem runs like this: a firm produces 3 kinds of commodities A, B and C and sell them in 2 different markets. The annual sales are given below. Here the situation is what? There are 2 different markets, 1 and 2, right. This is market 1 and this is market 2, and we are having 3 different commodities or 3 different products. They are denoted by A, B and C, right. So what is given in this table? Look at here. The production or the sale of the commodity A in market 1 is 12,000. The sale of commodity B in market 1 is 5,000, and the sale of commodity C in market 1 is 15,000, right. Likewise, the sale of commodity A in market 2 is 5,000 and sale of commodity B in market 2 is 18,000 and sale of commodity C in market 2 is 9,000. So this is all about the data which is given in the form of a table. What we have to calculate: point number 1, if unit sale of price of A, B and C are rupees 350, rupees 2 and rupees 150, then find the total revenue in each market with the help of matrix algebra. So sale of price of 3 commodities A, B and C means the price of a single commodity is given here. The price of a single commodity of A is rupees 350, it is of B of rupees 2 and commodity C is of rupees 150 and rupees 1 and 50 paisa. So we have to determine the total revenue in each market with the help of the matrix algebra. So what this problem actually represents: here 3 different commodities are given in 2 different markets, their sales are respectively also given here. Determine how much revenue is being generated by market 1 as well as market 2 by selling these 3 commodities. This is what we want to determine in case 1, right. 2, if unit cost of the above commodities are this, then find the gross profit. After that in second case, you will have to determine the gross profit. Gross profit means the profit of the firm 1 and then profit of the firm 2. Then we will add up the profits of these 2 firms, that will give you the gross profit. So let us see, we know how we will calculate or how we calculate revenue. You know, revenue is simply given as price multiplied by X. P is the price of the commodity per unit, be careful, and X the number of commodities sold in the market, because revenue is being generated by selling the product, not by the production of the commodities, right? So here A, B, C, 12,000, 5,000, 15,000, then 5,000, 18,000 and 9,000. This is considered as the matrix of the sale, or you can call it as a sale matrix, right? And P is given as rupees 3.50 for commodity A, and rupees 2 for commodity B, and rupees 1.50 for commodity C. To look at the formula of the revenue, revenue is always equals to price of a commodity per unit multiplied by X, that is number of commodities sold. So what is the sale matrix here? The sale matrix is sale matrix. The sale matrix is being represented as 12,000, 5,000 and then 15,000, right, for the market 1 for these three commodities, and for market 2 it is 5,000 and then 18,000 and then finally it is 9,000. So we call this matrix as sale matrix, right? The commodities sold in two different markets A and B. And what is the price matrix? Price matrix can be represented like this. See, price per unit of commodity are given as 3.50 and then rupees 2.00 and then 1 rupees and 50 paisa per each commodity. Now you can understand what we should do or what we must do. Simply, this is the sale matrix, that is X, and this is the price matrix, that is P. So R, the total revenue, is given by the sale matrix of the three commodities A, B, C in two different markets. It should be multiplied with their respective price per unit of commodities. So multiply these two matrices, you will get the resultant matrix as the total revenue generated by each of the markets 1 and 2. So if you multiply these two, 12,000 is multiplied by 3.50, you will get this, and then 5,000 multiplied by 2, you will get 10,000. 15,000 multiplied by 1.50, you will get this. Likewise, they take the second row of the first column and multiply it the price matrix, you will get these entries. Now sum up all these things, you will get 7,45,000 rupees is the revenue generated by market 1, and 67,000 rupees is the revenue generated by the market 2, right? So this is the total revenue we have calculated, which is being generated by two markets 1 and 2. In case 2, if unit cost of the above commodities are changed, rupees 2, rupees 1 and 50 paisa. For example, this price matrix has been changed, now it is rupees 2, 2.00, right? Rupees 2 and then rupees 1 and 50 paisa means half of the rupees that we can take as 1 upon 2. Now this is our price matrix, price per commodities, right? And this sale matrix remains the same, no change, right? So what we will do to calculate the total cost, the commodities sold and their per unit price should be multiplied. The same matrix, the sale matrix of three commodities is given here verbatim as we have taken in case 1, but the price matrix here has been changed. Now multiply these two matrices, you will get the total cost incurred, and the total cost incurred by these two markets is given by 36,500 by the market 1 and 32,500 by the market 2, right? Are you getting the point? If you multiply the matrix this with the price matrix, say first column 12,000 into 2, 24,000, 5,000 into 1, 5,000, 15,000 into half, 7,500. This is the product of first row with the price matrix. Now take the second row, 5,000 into 2, that is 10,000, 18,000 into 1, that is 18,000, 9,000 into 1 upon 2, you will get 4,500. Sum up all these numbers, the total cost by generated or incurred in these two markets 1 and 2 will be 3,65,000 in market 1 and 3,32,500 in market 2. Right. So this is the total cost. We call it as total cost. What we want to calculate, if unit cost of the above commodities are this, then find the gross profit. So how you will calculate the gross profit? Gross profit means what? We know that the profit is equals to, first calculate the profit. Profit is equals to revenue, total revenue minus total cost. And total revenue is what? So the profit P is equals to, revenue is 745,000 and 67,000. This is the total revenue. Minus cost is 365,000 by market 1 and 325,000 by market 2. So difference of these two matrices will give you the profit generated by two different markets 1 and 2. So the difference of these two, you will get 38,000 and 345,000, right? This matrix. So first element is what? The profit generated for the market 1, and the second element shows that the profit generated by the market 2, right? So this is how we can calculate the total profit earned by two different firms 1 and 2 by selling three different commodities A, B and C, and we have to finally calculate the gross profit. You know, gross profit means the profit of the market 1 plus profit of the market 2. So add these two entries, 38,000 plus 345,000. The sum is coming out to be 725,000, 725,000. So 72,500 is the total or the gross profit earned by these two firms 1 and 2 by selling these three commodities A, B and C. So students, this is how we can use the concept of matrices or the concept of matrix algebra to find out the solutions of the practical situations which we generally encounter in our day-to-day life, right? See, let us take another example. In North Delhi, there are 20 colleges and 50 schools. Each school and college have one PN, 5 clerks, one cashier. Each college in addition has one accountant and one head clerk, right? The monthly salary of each of them is as follows: PN rupees 100, clerk rupees 150, cashier rupees 250, accountant rupees 300 and head clerk rupees 350. Find number 1, the total number of posts of each kind in schools and colleges taken together. So what is given here? In North Delhi, there are two categories: 20 colleges and 50 schools, right? And each college have 5 employee, one peon, 5 types of employee, one peon, 5 clerks, one cashier, right? each college in addition has one accountant and one head clerk. So each school and college is having 5 types of employee: a peon, clerks, cashier, accountant and head clerk. The monthly salary of each of them is given below. Peon is getting 100 rupees, clerk is getting rupees 150, cashier is getting rupees 250, accountant is getting rupees 300 and head clerk is getting rupees 350. Find total number of posts of each kind in schools and college. How many total number of posts are there in 20 schools and 20 colleges and 50 schools? So consider A is equals to, what is this? A is taken as 20 and 50. This is a matrix which represents the number of colleges and schools, right? A represents number of colleges and schools because there are 20 colleges and 50 schools. We are representing them in the form of a row matrix, right? And let B is a matrix of what? 5 kinds of employee, right? So 1 peon, 5 clerks, 1 peon, 5 clerks and 1 cashier, right? And then in addition 1 accountant and 1 head clerk, 1 accountant and 1 head clerk, right? Each college in addition has 1 accountant and 1 head clerk, right? So there is no head accountant and head clerk here, so it will remain here 1, 5 and 1, okay? Each college in addition has 1 accountant and 1 head clerk. It means college is having additionally 1 accountant and 1 head clerk, which schools are not having. That is why I have taken here 0. So this is a matrix A, this is a matrix B. What we want to calculate? The total number of posts of each kind in schools and colleges taken together, right? So if we multiply these two matrices A, B, what you will get? See, consider the row matrix A is equals to 20, 50, which represents a number of colleges and schools in that order, right? We have taken B as this matrix, where column represents number of peon, clerk, cashier, accountant and head clerks, while row represents the colleges and school, right? They are what? Colleges. They are colleges. The second row represents the schools, right? So what is mentioned here? Each college in addition has 1 accountant and 1 clerk. So 1 accountant and 1 clerk is not possessed by the schools. So 1, 5, 1, 1, 1, they are the employee of the college. 1, 5, 1, accountant and head clerk are not available in schools. That's why I have taken them as 0. Now find out the product AB. If you multiply them, you will get it as 70, 350. This is the product of AB. Multiply these two, where first, second, third, fourth and fifth column represents the total number of peon, clerks, cashier, accountants and head clerks. So there are 70 peon, there are 350 clerks, there are 70 cashier, there are 20 accountant and there are 20 head clerks, right? So simply the product of the two matrices A and B will represent the total number of employee, whether they are peon, clerk, cashier, accountant and head clerk in colleges as well as schools all together, and this is what we want to calculate, right? So students, we should stop it here, this lecture. Now I will continue in the next lecture the remaining portion of the text. Thank you very much.